Good afternoon, students. Today we just want to review question 5, which came in May. This was paper 41. Let's just check the year. It was May, June 2023, paper 42. Just want to have a look at this question. Question number 5. It's an organic chemistry question. All right, so that's what we want to do. And then maybe in our next session, we'll look at a question which has to do with stoichiometry. Now, here we have a question about propane and propene. We are simply having these two hydrocarbons. One is an alkane, as in propane, and the other one is propene, which is an alkene. All right, so let's look at question 5a, part 1. When a molecule of propane, C3H8, reacts with chlorine in the presence of UV light, one atom of hydrogen is replaced by one atom of chlorine. State the term given to reactions in which one atom in an alkane is replaced by another atom. Okay, when I'm teaching this topic, I always remind students that, okay, now all of us have watched soccer at some point in time. A saturated team of soccer will have 11 players, but if you are to introduce a substitute, the other player must go out and the new player must go in. So that player who is seated on the bench is called a substitute. So it's going to replace someone who is injured, or maybe a coach has decided to pull them out. So if you want to answer that question, you can always remember this is some form of replacement, but the term that we use in chemistry is substitution. So our answer here is going to be substitution. Okay. All right. So our answer to 5a is going to be substitution. So that's the answer that we write here. Our answer would be substitution. Okay, let's write in small caps. Okay, substitution. This is a typical reaction for all alkane molecules, right? But we are being told that for this reaction to happen, there is need for UV light, okay? And then we are being asked, okay, what is the purpose of ultraviolet light in this reaction? We want this reaction to occur. All chemical reactions maybe have an NH barrier, something that prevents the reaction from taking place. So we need to overcome this NH barrier, and we can only do this by providing activation energy. So UV light here is providing activation energy. Provides activation energy to overcome the NH barrier. So that would be our answer here. It provides activation energy. Okay, and then the next question is talking about all the reactions which require ultraviolet light. Okay, so light in science is denoted by the word photo. Okay, photograph. Okay, that's a process that requires light. Okay, photosynthesis. That's when plants are making making food in the presence of light. So here, this one is a chemical reaction that requires light. So the term that we use here is photochemical. Okay, so we say photochemical. That would be our correct answer here. Photochemical reaction. Photochemical reaction. And then here it says, write the symbol equation when propane reacts with chlorine. Okay, you need to remember the symbol for propane is given up there. So it's going to be C. Okay, let's use caps here. So C3H8. Okay, and then we are going to say plus. Chlorine is always diatomic. Okay, so our chlorine will be diatomic. Okay, we're not going to use an equal sign when you're answering. I'm going to put an arrow. So instead of those lines that I'm putting in your exam, please put arrows. Okay, all right, so this is a substitution reaction. The carbon number of atoms is not affected, but we are going to substitute the hydrogens. So instead of 7, they're going to be, instead of 8, they're going to be 7. And incoming our substitute, the new player, Cl. Okay, and then we are going to have the other hydrogen that is being replaced. Remember, chlorine is a diatomic molecule, so it will react with the other chlorine atom. There we go. That is our reaction. But please remember here, you have to put an arrow, okay? We don't write chemical equations like this. I'm doing this on a PC, and it might take a bit of time for me to come up with the arrow. Okay, so this is substitution reaction. Right, and then they are saying a molecule of propene propene as opposed to propane. You see, here we now have propane. Now, if you check these molecules here, all right, if you check this is propane, all right, that's an alkane. But if you also check this one, this is an alkene, okay, the in part, okay, and the ain part. This is what makes them different. Propane is an alkane. Propene is an alkene. So we want to answer the question which says, explain why propene is unsaturated. Okay, that's what we want to look at here. Explain why propene is unsaturated molecule. All right. Remember, saturation and unsaturation has to do with presence of a double bond. So this one is unsaturated because there is a double bond. Okay, there is a double bond between. There is a double bond between, right, between carbon atoms. All right. So we have a double bond between our carbon atoms. So that's why we are saying this one is unsaturated. Okay. We have a double bond between our carbon atoms. That's why we have uh, we have our unsaturation there. Okay, right. So we have our propene there, and then we want to find out what then happens when we have our product. Okay, so we will have CH3. Okay, I'm going to have CH3. All right, we have CH3 here, and then we are going to have okay, CH3, and then we are going to have CH. Okay, then our chlorine both will come through Cl, Cl, so chlorine, and then we're going to have CH2. Okay, CH2, CH2, Cl. Okay, right. So no other product is formed here because what we are talking about now is we are talking of an addition reaction. All right, this one is substitution, but that one is addition. So we can actually have this reaction in comparison to actually look at what happens to alkene molecules and alkane molecules. Alkane molecules will undergo substitution reaction in the presence of UV, but even in the dark, the propene, the alkenes will undergo addition reaction. There is no need for an activator. There is no need for a catalyst. This reaction will undergo addition, or alkenes will undergo addition in the dark. And that reaction can also be used to distinguish between alkanes and alkene, especially when we use bromine, which is a colored substance. Thank you. I thought we should just review alkanes and alkenes.